Hybrid and electric vehicle transmission systems with electric motors and generators offer incredible opportunities in the automotive service market, and it's time for you to take advantage of this exploding market. The AT33EV diagnostic kit is a complete hybrid and electric vehicle motor generator unit or electric machine analysis tool for field use. Whether your business is automotive repair, reconditioning, remanufacturing, or salvage, the AT33EV will support the analysis and diagnosis of any transmission with permanent magnet or AC induction electric machines. The AT33EV provides superior testing capability of electric machines in the field, on the bench, or in the lab by measuring all of the major electrical elements such as DC resistance, impedance, inductance, capacitance, phase angle, current to frequency ratio, dissipation factor or tan delta, and insulation resistance. It also can perform rotor state of health testing, something no other equipment manufacturer or methods can offer. It can perform static only, dynamic only, or both static and dynamic testing that will provide the most thorough electric machine testing in the motor industry. Once the testing is completed, the test data can be stored, used as a test reference for testing other motors or generators, and it can be uploaded to a PC so the motor test report with data and performance signatures can be viewed, printed, and saved as a hard copy. Easy to use and a time saver, total testing time with the AT33EV on the vehicle or on the repair bench is less than 5 minutes, and testing can be performed with transmissions in or out of the vehicle. The AT33EV is used by major automotive manufacturers, hybrid and electric vehicle transmission remanufacturers, technical schools, and colleges, and is rapidly being adopted by the aftermarket service businesses for use in the growing areas of transmission diagnostics and state of health checks. Some motor generator test methods require you to use a light bulb. Others require you to push the vehicle that will only test one type of motor on one type of transmission with only one type of failure mode. Other methods use an LCR meter that have been proven in independent studies to produce unreliable, non-repeatable test results. This can cost your business thousands of dollars and reduce your customer satisfaction and trust. Other motor testers can cost 4 to 5 times the low purchase price of the AT33EV and deliver half the results. So why take a chance on what's being recommended by the amateurs when you can go with what the pros use for field testing hybrid and electric vehicle motors and generators and keep that customer satisfaction growing? The AT33EV provides a highly flexible, software-driven automated diagnostic system process that doesn't require you to push the vehicle, use a light bulb, use unreliable meters and methods, or use ultra-high-cost analyzers. The AT33EV can perform repeatable analysis on any type of vehicle, regardless of hybrid or electric vehicle manufacturer or system design. Now, let's take a look at how to test motors and generator circuits by using the AT33EV motor circuit analysis tool. Using the ALTEST Pro AT33EV motor circuit analysis tester on the vehicle utilizes the following steps: disabling the vehicle, preparing the vehicle for testing, electric machine testing, which involves dissipation factor and insulation resistance testing, static testing, dynamic testing, and uploading the test data. To demonstrate how to use the AT33EV on the vehicle, we'll be using the Toyota Prius. The very first operation is to remove the service disconnect from the vehicle in order to disable the high voltage system. Notice that the technician is using high voltage class 0 gloves prior to removing the service disconnect. Once the disconnect is removed, we can continue with AT33EV testing. The next step in the process is to open the hood and remove the beauty cover that blocks the power inverter cover from being removed. On this particular vehicle, the beauty cover covers the front bolts on the power inverter. Once the beauty cover is removed, the front bolts on the power inverter can be seen and removed. The next step is to remove the wipers, the wiper arms, and the wiper transmission system so that the rear power inverter cover bolts can be removed. Once the wiper transmission system has been removed, now all the power inverter cover bolts can be removed, and now we'll have access to the power inverter. Once all the power inverter cover bolts have been removed, the power inverter cover can be removed, and now the technician will check to ensure that there is no high voltage in the power inverter that's making its way through the system from the battery pack or from the bulk capacitors that are located inside the power inverter. Notice that he's wearing his high voltage class 0 gloves. Once it is safe to work on the power inverter, the technician will now remove the three-phase cable bolts holding the three-phase cable into the power inverter. Once these bolts are removed, the cable can be removed, and then the three-phase cables will have access for the AT33EV to perform its test functions. The next step in the process is to jack one side of the vehicle in the air so that one of the front wheels on this particular vehicle can be rotated. This is necessary to perform the dynamic test. Notice that the technician is using a safety stand for vehicle stability and safety. Now it's time to begin performing the test with the AT33EV. The first test is going to be the dissipation factor and insulation resistance test. There are only two instrument test leads that are used for this test. The yellow clip, which is used for the insulation resistance test, which is hooked to chassis ground, and the blue lead, which is connected to the number 2 or center phase of the motor. Once the insulation resistance test and the dissipation factor or tan delta test has been completed, the remaining two test leads from the AT33EV will be connected onto phases A and C, or 1 and 3, to perform a battery of static test. The static testing will include DC resistance, impedance, inductance, capacitance, current to frequency ratio, and phase angle. And the AT33 will then do comparative testing, which will compare the three phases against each other to determine the static motor condition. It's now testing phases 3 to 2, and then 2 to 1, and then finally 1 to 3. And now it will use that data, compare the phases against each other to find the motor static condition. When the static testing has been completed, the technician has the option of performing a dynamic test. The dynamic test requires that the motor or generator rotor be turned at a slow RPM so that a more precise stator test can be performed and a test of the rotor, permanent magnet rotor magnets, or the AC induction rotor bar state of health can be determined. Rotor turning is accomplished by turning one of the front wheels. When the dynamic test has been completed, initial test results will be displayed. More detailed information is also available in the tool submenus, or the test can be uploaded. The total time to disable, test, and reassemble this vehicle was less than 1 hour. For more information on AR&D motor testing equipment or any of our hybrid courses, please visit our website. Thank you.